1.5 equations. Equations state that two mathematical expressions are equal. Their solutions are also called roots. They make the equation true. Linear equations of the first degree take the form ax plus b equals 0. X is only to the first power, so that is why it is first degree. Okay, our first example is 17x plus 8 equals 5x minus 28. So we are going to use reverse order of operations. Okay, so we want to get the x's on one side. They'll stay positive on the left, so it's positive 5x. Subtract it. That gets us 12x plus 8 equals negative 28. We are trying to isolate x. So subtract the 8. Goes to 12x equals negative 36. Last step is to divide by 12, and x equals negative 3. You might also come upon a literal equation where it's mostly variables. You have to rearrange for a specific variable. So we have a equals 2LW plus 2WH plus 2LH. And we're being told to solve for W. So we have to first identify where is the variable that we want. We want W, it's in this term, to this one. So our goal is to isolate W. And our first step is to get rid of this 2LH, move it to the other side by subtracting. So A minus 2LH equals 2LW plus 2WH. Now we see that W's in both terms, so it's a common factor. We're going to take it out just like we do for GCFs. W times 2L plus 2H. Now W is multiplying the parentheses 2L plus 2H, so we need to divide by the 2L plus 2H. So it will cancel on the left. And we have now isolated W, and it equals A minus 2LH over 2L plus 2H. Quadratic equations of the second degree equations because our highest exponent is 2. Its standard form is ax squared plus bx plus c equals 0. One way we can solve it is solving by factoring. We have to have the quadratic equal to 0. So if it's not, we have to get it in that form. So we need to equal 0, subtract the 5 to the left side. X squared plus 13x minus 5 now equals 0. Okay, factor as you normally would. A is 6, B is 13, C is negative 5. A times C is negative 30, B is 13. What multiplies to negative 30 and adds to 15, at 13? It would be positive 15 and negative 2. So put it in factored form, x minus 15 times x minus 2 equals 0. Last step, we need to set each factor equal to 0 and solve. So we need to set x minus 15 equals 0, so x equals 15, and set x minus 2 equals 0, x equals 2. So we get x equals 15 and 2. We can also simplify quadratic equations using square roots. So we see we have quantity x plus 7 squared equals 34. Instead of FOILing out x plus 7 times x plus 7, why don't we use square roots? So x is in the parentheses. It's getting squared, so we want to square root both sides. Okay, so on the left, it cancels if we drop down the x plus 7. So in an equal, there is no square root of 34. Its only factors are 2 and 17, and those are both prime. So we cannot break down square root of 34. We can just get a positive and negative square root of 34. The last step, to isolate x. X is having 7 adding to it. So the opposite is subtracting. So x now equals negative 7 plus and minus the square root of 34. If it's asking for an exact answer, this is the exact answer. If it's asking you to round, you may use a calculator to find the square root of 34 and solve it out further. Completing the square. If a quadratic equation does not factor readily, then we can solve it by completing the square. To make x squared plus bx a perfect square, we add the quantity b over 2 squared, which is the square of half the coefficient of x. So we're going to be using just x squared plus bx. Okay, we're going to start by looking at our equation. 2x squared plus 12x minus 4. Two x squared plus 12x minus 4 equals 0. This is not factorable in the fashion that it's in. So we need to get it in the form ax squared plus bx. So we need to add c to both sides. So add the 4, or subtract it if it was positive. So we have 2x squared plus 12x equals 4. At this step, we need to make sure that a equals 1. And if it's not 1, we need to take out a GCF. So we're going to take out a GCF of 2 only on the left side. So 2 times x squared plus 6x equals 4. Okay, so now we're going to continue by completing the square. We are going to take b over 2 and square it. So that means we have 6 over 2 quantity squared. 6 over 2 is 3. 3 squared is 9. So we are now at 2 times x squared plus 6x plus 9 equals 4. Now this outside 2, it would also multiply the 9. So when we add the 9 to the other side, it has to get multiplied by the 2 as well. And this is only the case when we took out a GCF to get a equal to 1. So the right hand side, 9 times 2 is 18, plus 4 is 22, equals x squared plus 6x plus 9, and it's all multiplying by 2. So this breaks down to 2 times x plus 3 quantity squared equals 22. Now solve for x just like we did on the previous problem, 5 by 2. We go to x plus 3 quantity squared equals 11. Square root both sides. X plus 3 equals plus or minus 11, square root of 11. Subtract 3. X equals negative 3 plus or minus root 11.